Let's kick off this explainer by diving straight into a secretive, multi-billion-dollar scientific race that's happening right under our noses. For the entirety of human history, we've treated aging as an inevitable destiny, a one-way street. But what if it's not? What if aging is actually just a solvable biological problem?
I mean, for millennia, we've just accepted wrinkles, physical weakness, and eventually death as entirely natural parts of the life cycle. We've written poetry about it, built entire philosophies around it. But we really have to ask ourselves here, is aging actually a biological choice? What if that ticking clock isn't permanently wound?
So let's get into part one, the zombie within. To understand this, we've got to look at the microscopic level. Because your body is constantly changing. Every single second, trillions of cells are dividing, repairing, and replacing themselves. But over time, this incredibly complex machinery kind of starts to stutter. Our cells suffer from severe DNA damage, general exhaustion, and the weakening of our mitochondria, the actual powerhouses of our cells. And all of this leads to something much more sinister hiding right inside our own tissue. The core problem is basically this. While normal cells do their job, they heal, divide, and eventually replace themselves, some damaged cells enter a state called senescence. Scientists affectionately, or maybe terrifyingly, call these zombie cells. They stop dividing, but they absolutely refuse to die. Instead, they just sit there, accumulating in your body, slowly secreting toxins that cause chronic inflammation. This actually accelerates the aging of the healthy cells around them, eventually leading to disease. It's like a bad apple spoiling the whole bunch. Which brings us to part two, the 2006 breakthrough. For decades, clearing out the cellular damage was considered pure science fiction. But in 2006, the biological world was completely turned upside down. Researchers discovered that by introducing a very specific group of genes, which we now call Yamanaka factors, they could isolate ordinary, aging adult cells and partially reset them into a much younger, more vibrant state. To wrap our heads around this incredibly dense science, just imagine doing a factory reset on an old, glitchy, damaged computer. It clears out the software bugs and makes the machine run literally like it did the day you bought it. That is essentially what these scientists figured out how to do to human cells. They found the biological reset button. This process is called epigenetic reprogramming. Harvard researchers like Dr. David Sinclair focus heavily on this exact mechanism. He suggests that aging isn't necessarily the loss of our core DNA, but a loss of the information that reads the DNA. Think of your DNA as the music on a compact disc, and epigenetics as the laser trying to read it. Aging is just a bunch of scratches on the CD. The music is still there. Epigenetic reprogramming polishes the CD, repairing those scratches, without the cell losing its specialized identity, so the beautiful music of a healthy cell can play properly once again. So the absolutely crucial point here is that this isn't just theory anymore. By modifying these Yamanaka factors in laboratory experiments, scientists have already successfully reversed aging in animal tissues by an astounding 75%. Older mice with age-related damage started showing genuine signs of biological rejuvenation. Their tissues repaired faster. They literally grew functionally younger. And we are rapidly moving beyond lab mice right now. The FDA has officially cleared the first human trial for an age-rejuvenating gene therapy called ER100. This specific trial focuses on using epigenetic reprogramming to restore vision in blind subjects by actually rejuvenating the cells in the eye. It's literally the very first step toward human age reversal in a clinical setting. However, there is a terrifying catch we absolutely have to acknowledge. Resetting cells sounds like a total miracle, right? But doing it too aggressively could trigger uncontrolled cellular growth. If you push a cell all the way back to an embryonic state while it's still inside a living adult body, it loses its identity entirely, and uncontrolled cell growth is exactly what we call cancer. So it's a massive biological tightrope walk. Because of that, we arrive at part three, the rise of senolytics. Due to those dangerous risks associated with cellular reprogramming, other researchers are tackling our biological clocks from a completely different angle. Instead of trying to reset damaged cells, what if we just take out the trash? Senolytics are highly experimental drugs designed specifically to hunt down and selectively destroy those senescent zombie cells we talked about earlier. By clearing these toxic cells out of the tissue, the chronic inflammation drops, and the surrounding healthy cells can finally function better and breathe again. Animal studies have already shown this can dramatically improve physical function and even extend lifespan. But you don't actually have to wait for experimental biotech to arrive to do something about this. Figures in the space, like tech entrepreneur Brian Johnson, are comprehensive, documented routines to prove that lifestyle optimization can drastically reduce your biological age right now. We're talking about optimizing nutrition, getting flawless, high-quality sleep, strictly avoiding toxins like smoking, and mimicking the habits found in blue zones, those regions of the world where people naturally live to be over 100 at staggering rates. Your daily choices are truly the first line of defense against cellular decay.
All right, moving on to part 4, the billion-dollar race.
The quest to cure aging has evolved into a highly lucrative real-world industry. Tech billionaires and major global investors are quietly pouring billions of dollars into secretive private labs. And they aren't just using traditional chemistry either. They're leveraging advanced artificial intelligence to simulate and discover powerful new anti-aging molecules and treatments faster than humanly possible. It's a cutthroat race because whoever unlocks the first true age reversal pill won't just win a Nobel Prize, they are going to completely transform global medicine forever. As this technology advances toward arguably becoming the largest industry in human history, we kind of have to pause and ask ourselves, if a treatment became available tomorrow, would you take it? Knowing the risks, knowing the highly experimental nature of reprogramming the literal building blocks of your body, are we actually ready for these treatments on a personal level? That brings us to our final section, Part 5, the dark side of immortality. Slowing down the biological clock sounds like an absolute miracle on paper, but it brings up some profound and frankly terrifying societal implications. Just think about the sheer scale of the ethical dilemma here. If we can suddenly cure aging, who actually gets the cure? We could be looking at extreme wealth inequality where only the ultra-rich can afford to stay young, creating a literal biological divide in the human species. Plus, if nobody passes away from old age, we face a very real threat of global overpopulation. And what about the psychological effects? How does the human brain even handle living for 2 centuries? Really think about this number, 150 years. Could our global society, our global economy, and our fragile psychology even survive if humans routinely live to be 120 or 150 years old? Imagine having to work for a solid 100 years before retirement. Imagine the shifts in housing, resources, and family dynamics. The structural changes to our world would be totally earth-shattering. Mortality has always been the defining boundary of the human experience. It shapes our art, our urgency to reproduce, our religions, and the way we structure our limited time. If aging changes, humanity changes with it. If we alter that boundary by defeating aging, we fundamentally alter what it means to be a human being. But despite all these massive ethical hurdles, science is marching forward. Right now, in state-of-the-art labs around the world, humanity is making a historic pivot. We're no longer simply accepting the decay of aging as a natural law. Through epigenetic reprogramming, senolytics, and AI drug discovery, we are actively, aggressively fighting back. And this leaves us with our final thought for this explainer. The question is no longer whether scientists want to reverse aging, or even if they have the funding to try. The much darker, more profound philosophical question we all have to face is this: what happens to our world, and to us, when they actually succeed?